We've actually already talked about phosphorus quite a bit in the renal section because it's also influenced by glomerular filtration. And so I'm going to approach kind of talking about phosphorus in two ways. One, I'm going to talk about it from kind of the hormone vitamin stance, and then we'll talk about those determinants of serum values. And of course, these are very related. So remember that PTH works to increase calcium, but it then decreases phosphorus. And so if you had an excess of PTH, let's say, from a parathyroid secreting tumor, you would imagine that while it would increase calcium, it would decrease phosphorus. And the opposite would be true if you had a decrease in PTH from hypoparathyroidism. That would result in an increase in phosphorus. So that's an example of kind of how that works in a different way. Vitamin D, of course, increases both calcium and phosphorus. And so this works kind of in different ways. So intestinal absorption vitamin D will increase calcium absorption in the intestine, and it'll increase phosphorus absorption in the intestine. But there are other things that can then decrease our phosphorus. But one thing to consider is vitamin D toxicosis. You could have marked increases in calcium and phosphorus, for example. And I'm not actually going to mention calcitonin because it's certainly not as common of an issue. So other things that are going to influence phosphorus levels would be the age of the animal, and of course this is bone growth related. And so bone growth, so if you use adult reference ranges, these young animals, usually less than a year and a half, will have an increased phosphorus. And this can sometimes be, if the high end of normal is around 5, we can see it up to 6 and potentially in the 7s as well. So that's hyperphosphatemia related to the age of an animal. And again, this has to do also with bone growth. And so I'll mention something about that in a second, just in terms of like lactation and how sometimes that can alter your phosphorus. Another thing to consider is going to be, of course, glomerular filtration. So I'm going to write it as GFR. So we've talked about the fact that if you have decreased GFR, of course, some from maybe pre-renal causes such as dehydration, renal causes such as renal disease, and even post-renal causes such as obstructions in your abdomen, that's going to result in an increase in phosphorus, because phosphorus is essentially a waste product in a lot of ways. It's very plentiful in the diet, so we tend to excrete a lot of phosphorus. So if you have decreased glomerular filtration, you can see hyperphosphatemia. And I would say this is kind of the number one cause of why we see increases in phosphorus, has to do with decreased GFR, except in young animals, of course. So GI absorption, and this relates to vitamin D above. So GI absorption and certainly diet are going to impact phosphorus. So GI absorption, if it's under vitamin D, it's going to increase GI absorption. But again, since dietary phosphorus is very high, it's not like we need to absorb a tremendous amount of phosphorus. We do excrete a lot of phosphorus. And so again, that case of the animal that has perhaps vitamin D intoxication, you're going to see tons of phosphorus being pulled out of the GI tract, causing hyperphosphatemia. And if you have GI disease where you have malabsorption, you could get a low phosphorus, although that seems rather uncommon. Diseases such as, again, vitamin D toxicosis, or if you had a diet with a low calcium to phosphorus ratio, that could impact your phosphorus levels. Another thing that's going to influence our phosphorus levels is going to be how much phosphorus do you deposit in your bone versus how much do you reabsorb from your bone. And we can actually see abnormalities in mobilization of phosphorus in animals, especially cows, and peak lactation, certainly. A last thing to consider is intracellular to extracellular shifts of phosphorus. I think a really good example is muscle. So here's some striated muscle, and it gets damaged. And of course, what lives in muscle? ATP. What's the P? Well, it's phosphorus. And so we tend to see really high increases in phosphorus with muscle disease, but then this actually ties up calcium, so you get that calcium times phosphorus product, and then you actually get mineralization of that dead muscle there, which decreases our calcium, but our phosphorus still stays high because there's so much of it. So just an example of why we get hyperphosphatemia in cases of really severe muscle injury. So in terms of reasons why you might get a low phosphorus, which is relatively uncommon, of course, so that there's our GFR if it's decreased, but an animal who's being diuresed, you'd expect a low phosphorus potentially. Or like I mentioned, an animal with really severe GI disease might have a lower phosphorus. Again, that's very uncommon. So I only have a kind of a couple things to say about magnesium. Magnesium is both calcium-like and it's phosphorus-like. It's calcium-like because around 40 to 45% of it is bound to albumin. And that means around 50% of it is free magnesium, similar to calcium. But again, it's not as important and it's not as influenceable as calcium is. So there's, again, bound fractions and then there's free fractions. It's also calcium-like in that it's very kind of dependent on GI absorption. So GI absorption, meaning that with GI disease, you can have a lack of magnesium, and that would be one of the ways that you could have a decrease in magnesium. PTH, so it's similar, right? So PTH increases, of course, PTH, right? How does it work? Well, it increases calcium, it decreases phosphorus, but it also increases magnesium. So PTH is going to work to increase magnesium as well, but remember the driver is calcium. So it's phosphorus-like because it is dependent on GFR. So if you have a dehydrated animal, you're going to see an increase in magnesium. So decreased GFR from dehydration or renal disease, you'll see an increased magnesium. And it's intracellular, similar to phosphorus. So with cell death, you'll see increases in phosphorus. The diseases related to magnesium are not really numerous. We don't really look at magnesium first, but I will say one thing. It can be differentiating for two diseases, and they're really more large animal diseases, so I know a lot of people just stopped listening if you hadn't already. But milk fever that we see in cattle, and then grass tetany that we see in animals that are grazed on really lush grasses, the magnesium's actually differentiating. So I certainly can't explain all the risk factors and things that lead to milk fever, but I will say in milk fever, the animals are hypocalcemic, and this hypocalcemia, of course, it decreases in ionized calcium, leads to stimulation of the parathyroid gland to make PTH. What did we just say about PTH? It increases magnesium as well as calcium. So you'll see an increase in magnesium. Whereas grass tetany, the problem is the lush grass, and this lush grass has very low magnesium. And so you have a low serum magnesium concentration. And this actually stimulates PTH, weirdly enough. And it does this because you have a low calcium as well, for lack of really how to explain it. And so this low magnesium, though, makes your PTH gland not work. And so you also become hypocalcemic. So in grass tetany, you have a decrease in calcium and a decrease in magnesium, whereas in milk fever, you have a decrease in calcium but an increase in magnesium.